Electrolysis of molten and aqueous compounds. Do you know the differences between them? So this question says magnesium chloride can be electrolyzed. The diagram below shows two experiments for the electrolysis of magnesium chloride. Look at the difference between the two. They're pretty much the same apart from the fact that this one is molten magnesium chloride and this one is aqueous because it's dissolved in water. That makes a difference to what gets produced at the end. So to figure out what the difference is, you need to think about what ions are in those two compounds, or what ions are in the two electrolytes. So for the first one, because it's molten magnesium chloride, it's basically magnesium chloride salt that has been heated and melted to a liquid. So inside that electrolyte, all you have are two ions. You have magnesium ions, Mg2+, and chloride ions. Those are the only two ions floating around in that liquid. For magnesium chloride dissolved in water, you still have Mg2+ and Cl- ions floating around, but because it's dissolved in water, there are a few ions which get released from the water ionizing. So that's always the same. If it's dissolved in water, it's always H+ ions and OH- ions. Both of those come from the water, from the H2O. The H2O basically splits up into H+ and OH- ions. So that makes experiment 2 slightly trickier to figure out in terms of what products are being made. The question says, in experiment 2, a gas is produced at the negative electrode. Name the gas produced at the negative electrode. If this was a question for experiment 1, the negative electrode will attract the positive ion, which in this case is Mg2+. So you can automatically say magnesium metal is produced at the negative cathode. But here for experiment 2, because it's in solution, we've actually got two different possible ions that could go to the negative electrode, the cathode, and discharge. And you need to know the rules of how to decide which one gets discharged. So for positive ions, it's always the one that's less reactive that goes to the electrode to get discharged. So out of magnesium and hydrogen, you've got to think which one is less reactive. It's actually hydrogen. If you know your reactivity series, hydrogen is less reactive. So that means hydrogen, H+ ions, are going to travel to the cathode, to the negative electrode, and they're going to turn into hydrogen gas. They're going to gain electrons. So the gas produced here is hydrogen. And it carries on here and it says, suggest why magnesium is not produced at the negative electrode. And simply put, you just say hydrogen is less reactive than magnesium. Now, for the last part, we're asked to write a half equation, and this is for the positive electrode. So that's the one that's going to discharge the negative ions. So in experiment 1, the negative ion is chloride. So that's going to get attracted to the positive electrode and it's going to release chlorine gas. For experiment 2, again, is slightly more complicated because we've got two negative ions. So we need to figure out which one of the two gets released. In this question, they've basically told us it's chlorine, so we don't need to do it, but let me explain anyway. For negative ions, it's always the halogen that goes to the positive electrode to get discharged. If a halogen is not present, the OH- goes to the electrode to get discharged and release oxygen. So because a halogen is present, a group 7 element is present, which is chlorine, it means the chlorine goes to the positive anode to get discharged. What we need to do now is to create this half equation. So the first thing we notice here is chlorine is diatomic. They've given us that already. They've called it Cl2. So we need to balance our chlorines now. Because we have two chlorines on the right, we need to have two chlorines on the left. So we need to add a big 2 in front of Cl-. Now the other product here, to turn Cl- into a Cl atom, you need to remove an electron. So for every chloride ion you have, you need to remove one electron. So because you have two chloride ions, you need to remove 2 electrons. So the answer here is 2E-.